Hello, good morning one and all. Today's presentation topic is Introduction to Midas CIM. First of all, I would like to introduce myself. I am Joseph Paul, Technical Support Engineer at Midas IT. I have over 5+ years of industrial experience. I have completed my Masters in Structural Engineering from VNIT Nagpur. I have been involved in the design of various infrastructure projects like bridges, flyovers and cooling towers. I have also worked at project planning and site execution level. Midas CIM is a platform for bridge information modeling. CIM stands for Civil Information Modeling. You all might have heard about BIM, that is Building Information Modeling. All the BIM softwares available right now in the market majorly caters to vertical structures. But it is at this juncture CIM comes into picture. CIM majorly deals with horizontal structures. In today's session, we will discuss about BIM for bridges introduced by Midas, that is CIM. So these are the contents of today's presentation. First, we shall go through the current BIM process. Then an introduction to CIM shall be discussed. Further, to understand CIM, we shall be modeling a PSC box superstructure, followed by reinforcement and tendon modeling. This shall be followed by the interface between CIM and Midas Civil. Then we shall be discussing about the interface between CIM and Midas Drafter, in which we shall cover drawing generation, bar bending schedule and quantity calculation. Once this is done, we shall go through few of the unique and special features of CIM like clash check, smart template, parametric modeling and slope modeling. Finally, we shall also discuss about interoperability of CIM with other BIM platforms. So first, let's discuss about the current BIM process. In any project, we majorly have three phases. That is planning phase, simulation phase, and output phase. The goal of the development of the solution is to fully integrate the linear-based planning tools into the above mentioned three stages of a particular infrastructure project. We propose CIM to be a global integral environment for any type of infrastructure through BIM. So, in planning phase, we will be proposing the type of bridge. For example, suspension bridge or cable stayed bridge, etc. We shall also be choosing the alignment of the bridge, type of materials, concrete properties, tendon properties, and cross-section of various members. So, when it comes to planning of any linear infrastructure projects like roads or tunnel, it's driven by alignment-based modeling. We also have provisions for detailing of rebars, tendons, and stiffeners. Once the planning part is completed, the simulation part is carried out. In this stage, the model is analyzed and all the checks like structural and serviceability checks are performed. So, in this phase, to satisfy the checks, we might have to make changes to the initially proposed model. Now, these changes are incorporated into the initial planning phase. Once the model is finalized, we take out the output. The major outputs are construction drawings and quantity of materials. In a brief, CIM provides a complete integral platform throughout a project's life cycle. We shall discuss about this in detail in the upcoming slides. Through CIM, we propose a one-stop solution for all the geometric modeling needs through BIM. The analysis and design check part is carried out through one of our flagship products, Midas Civil, and the construction documentation part through one of our integral product, Midas Drafter, which generates 2D drawings and bar bending schedules. So basically, the 3D model shall be developed in CIM, and then for carrying out its structural analysis, we export the analytical model to Midas Civil. From CIM, drawings can be generated directly using Midas Drafter. The design environment mentioned verbally will be explained in the following video to make it easier to understand. First, a complete geographic information is imported. Using the predefined libraries, we can align it along the bridge alignment line to create a complete geometric model. The detailed library modeling part is also catered through CIM. Changes in the alignment can easily be updated in the CIM model. It also supports rebar and tendon modeling for accurate quantity calculation and preparing construction drawings. Two-D drawings can be generated effortlessly in CIM. Detailings can also be generated easily. It also supports simulation of construction phases and can perform quantity calculation as well as clash check during the construction phase. For analysis and design, it can be linked with Midas Civil. Once the bridge is operational, the maintenance and management can also be carried out using CIM. Overall, a complete life cycle through Midas CIM is proposed, wherein we can design, build, and operate through one solution. I believe that you have got a brief idea about the possibilities of CIM. Now let's see an example of practical modeling in CIM. Users who are familiar with Midas Civil knows that Civil is a node-to-node modeling software, whereas CIM is an object-oriented modeling software. Now, to understand about the geometric modeling in CIM, we shall be modeling a PSC box superstructure. We have defined the span as 40 meter. Now we are importing the PSC box cross section from a DWG format file. Cross sections can also be drawn using the sketch mode in CIM. Now the import is complete. Now we are defining the path. Now the cross section is being assigned to the defined path. Now we are defining this as a curved library. Let's familiarize with the term curved library. A curved library is a library which is associated with a path. So you can define structures like main longitudinal girders, medians, or PSC box spans as curved library, and it can be imported and reused whenever required. Now let's see how the rebar modeling is done in CIM. First, the cross section is chosen. As you can see, all the properties like diameter of the rebar, cover, hook details can be entered as input. While defining the rebar, it can also be linked with the member edge so that when there is a variation in the member dimension, the rebar gets automatically adjusted. Here, the transverse rebar is defined with the member edge as reference, and the longitudinal bar is defined with transverse bar as reference. Now we have defined the transverse and longitudinal bar in the cross section. Now we can use the array function to generate the rebars till the required target plane. So this tool is very helpful in rebar detailing. Array function is used to provide rebars at equal spacing. So now this is the final view after the rebar detailing is complete. Now let's see how the tendon modeling is done. Here we are importing the earlier defined curve library. We can define anchorages from the existing database. All the properties like the material, strand diameter, number of strand, duct dia can be defined. The tendon profile can be generated by choosing the profile points using mouse clicks in the section views, or can be taken as input from Excel file. Here we have taken the tendon profile data from Excel. The tendon modeling is now completed. Let's see another method of tendon modeling. In this method, you can either generate or edit the tendon profile by just using mouse clicks on the section and plan view. Here, we have shown how the tendon profile can be edited using mouse click method. Now let's see how the substructure geometric modeling is done. We can either import the cross section from the DWG files, or we can draw them in sketch mode of CIM. Here we are importing the cross section from DWG file. Now we are defining the peer cap member. Thus the peer cap is now modeled. Now the properties of the peer are being defined. Thus the peer cap and the peer is modeled in CIM. Similarly, we can model the foundation as well. This is the final geometrical model developed for the substructure. If we consider a bridge alignment, the substructure is located at certain point locations along the alignment. We can now save this as a point library. It can be imported and reused whenever required, like the curve library. Now let's move on to the substructure reinforcement modeling. In the superstructure reinforcement modeling, we have already seen longitudinal and transverse modeling and the use of array function. Using this array function, the stirrups can be very easily modeled in the peer cap even along a tapered section. The stirrup modeling of the peer cap is now complete. The modeling of circumferential reinforcement of peer is now shown. So this is the view after the reinforcement detailing of the pier is complete. The final view after the reinforcement modeling of the entire substructure is shown now. Let's discuss about assembly unit now. Earlier we had defined the pier substructure as point library and PSC box as curved library in CIM. Now we can define an assembly unit by importing all the libraries which we have created. Now we are defining the path of the assembly unit. Through constraint point function, we will be defining the location of the piers. We are assigning the location of the piers now. We are assigning the PSC box superstructure to the defined path. The substructure and superstructure are assembled to form a unit. This assembly unit is used to define a layout, about which we shall be talking next. The assembly unit can be assigned to any layout. Here, the layout refers to the alignment of the bridge. Here, the straight assembly unit is assigned to a curve layout. In the assembly unit, we had used a straight span of length 40 meter, and in the video, we have defined a layout of span 45 meter and radius of curvature 250 meter. Now we are assigning the assembly unit to the layout. And you can see that the geometry, tendons and the reinforcement gets modified automatically. So whenever there is a change in the alignment, it can be updated comfortably using this layout feature. Now let's discuss about the CIM and Midas Civil Interface. Once the modeling part is completed, comes the analysis and design part. CIM provides an interface with Midas Civil where an analytical model can be exported to Midas Civil. Once the analysis and design part is completed, the model can be imported back to CIM. The model developed in CIM is exported to Midas Civil as shown in the video. Further, the analysis and design can be carried out. So now you can see that the CIM model has been exported to Civil. Now we shall discuss about CIM and Drafter Interface. When analysis and design stage is completed, we need to generate construction drawings, detailings, and bar bending schedule. The structural drawings will be produced in conjunction with another Midas product, that is Midas Drafter. The rebar detailing, tendon drawings are just one click away. Now let's see how the drawings are generated using CIM. From the CIM model, we shall be generating drawings. Any section can be cut at any location and the corresponding geometric, reinforcement and tendon drawings can be generated smoothly. You can create the reinforcement from assembly unit or from defined libraries. We also have a provision for creating 3D isometric views, which is useful for monitoring project progress. By referring to the satellite coordinates defined in CIM, absolute coordinates or relative distances can be detected even in drawings. Now let's see how the bar bending schedule is generated using CIM. From the CIM model, we have obtained the final drawing with annotation as well as the bar bending schedule. Another output which can be obtained is the quantity of the materials, about which we shall see next. Quantity calculation output can be taken out in Excel format from CIM. It shall carry each and every information about the elements. Now, let's see what makes CIM and Drafter Interface special. The Midas drafter's drawing is linked with CIM. So, when the shape of the member is changed in the model, the shape of the member in the drawing is also updated automatically as the drawings are linked with the model. Similarly, the dimension lines and the labels also get updated automatically. Now we shall discuss briefly about few unique and special features available in CIM. The first feature of CIM, which I would like to highlight, is clash check. After the design, many clashes are commonly found. For example, there might be clash between reinforcement and tendons. All these clashes can be identified in the planning stage itself. The above image shows a project application which was done using CIM. In PSC box superstructure, usually in blisters or diaphragms, due to dense reinforcement, clash between reinforcement and tendons are usually detected. These clashes can be identified at planning stage and rectified easily. Through this detailed model, the construction can be made simpler by carrying out various clash checks during the planning stage itself. During clash check, you need not prepare the complete model to identify the clashes. You can also just model the region where the clash might occur and identify the clashes. In this case, clashes has been identified between the saddle and the reinforcement. The 2D drawings of the clashes can be generated and it can be shared with the contractor as well as the consultant. So this feature has a wide practical application. In this example, a pylon with dense reinforcement is shown, and the cable clashing with the reinforcement is also shown. We are resolving the clash by making changes to the spacing of the reinforcement. Once the interference was reviewed, the configuration can be registered as a template to facilitate re-verification. Now let's discuss about a unique feature of CIM, and that is Bridge Modeling Smart Template. All those who have used Midas Civil shall be aware of the different bridge wizards which are available in Civil. It makes the modeling simpler and easier. The same function is available in CIM. Smart Template is a quicker way of modeling during the planning stage. Templates are available for PSC beam bridge, PSC box bridge, cable stayed bridge, and suspension bridge. Now let's see a practical application example of the Smart Template. This is an example of use of these smart templates in planning stage. Here you can see that different structural types of bridges can be modeled quickly using the smart template. Through the provision of satellite image mapping and topography mapping, we could geolocate the model through real-time coordinates. It can be efficiently utilized in planning stage that requires landscape and cost review for each structural type. Now, let's discuss about another feature, that is parametric modeling. As shown in the video, you can control the shape of the longitudinal structure according to the fed information. In a civil structure, almost every section has a gradient, and there are even sections with two-sided gradient. Once the parameter is changed, the model gets updated accordingly. Parameters makes it easier for reusing the elements. So when it comes to parametric modeling, CIM provides various parameters for different elements wherein you can make changes to the model and the model gets updated based on the parameters applied. Apart from geometric modeling, CIM also covers terrain and slope modeling. Various terrains can be modeled through input of 3D data or site data through surface modeling or topography modeling. Now let's see a terrain and slope modeling of roads in CIM. Next, we are going to discuss about interoperability of CIM and other BIM platforms. Since BIM is all about data exchange, CIM also caters to data exchange using IFC file format for various other BIM platforms. CIM models are compatible with Autodesk Revit via IFC file format. CIM also supports data exchange with Autodesk Navisworks, a construction simulation tool using IFC file format. CIM model can also be exported to InfraWorks via IFC format or DWG format. Finally, it can also be compatible with rendering tools for presentations. Rendering simulation such as vehicle movements and light changes can easily be added to models designed with CIM. Here, it is exported to Lumion software. I kindly request all of you to fill a survey poll which shall help us in better planning and development of our product. This shall be followed by a Q&A session where we shall be answering all your queries. So that's it from my part. I hope that all of you have got a brief idea about Midas CIM. If you want to know more about CIM and to access the tutorials, you can visit our website cim.refined.site. In case if you need any technical support, we would be glad to help you out. You can reach us at globalsupport.midasuser.com. Link of both the websites are shown on the slide. I would like to thank all of you for attending the webinar and have a great day. Thank you.